This is 39 off of the AP Calculus AB multiple choice cumulative problems. So what is the general solution for the differential equation? dy over dx equals cosine of 8x over cosine of 4y. We know we have to eventually anti-differentiate so that we can get it into a form without the derivatives. So let's cross multiply first, then I can separate the variables. We'll see if we have separation of variables after that. So cross multiply, I get cosine 4y dy equals cosine 8x dx. We see x's and y's are nicely separated, so I'm going to take the antiderivative of both sides. But notice that both of these are not quite ready for antiderivative rule. We do have rules for cosine of u, but that 4y, we need to make sure we keep track. So we go through U-Substitution, u equals 4y, du over dy is 4, dy equals du over 4. So also something to keep in mind is when you take your antiderivative of integral where your u value is just a coefficient, your antiderivative will always produce a coefficient that is the reciprocal. So this is basically cosine of u with a 1/4 in front. This is basically cosine of u with a 1/8 in front. So it's always going to be the reciprocal out in front. So we can always go through U-Substitution, but it's always nice to be able to just quickly move something out, especially if it's something that is it's easy in terms of relatively simple u values. So we can just convert those to be u's and push those coefficients out as reciprocals. And now we have integral of cosine of u and integral of cosine of u. We take the antiderivative of both sides. Cosine becomes sine on this side. Cosine becomes sine on this side as well. This cosine is going to be 4y. This u value is with 8x. And then we're down to these terms with a plus c, of course. And now if I multiply everything through by 8, because that's the largest denominator, then I can make it match answer choice C, because 8 times divided by times 1/4 is 2, 8 divided by 8 is 1, and then 8 times C is still a constant, so that's why that C is still there. That 8 just got absorbed into that C. So this answer choice matches C. All right, number 40, the amount of bacteria in the petri dish increases at a rate proportional to the amount present. So we can say B prime is equal to K times B, or dB dt equals K times B. And if I just take the antiderivative, this is the most common differential equation that we've seen with these types of word problems. So this should be recognizable in the form of y is equal to ce to the kt. But basically, we divide both sides by b. We move the dt over to the right side. Natural log both sides. Natural log on the left side. Power rule on the right side. Exponentiate both sides with base e. Clean the left side up to be just b. The right side we can split up and then bring that c down in front. So I like to start off with these problems once I have my equation, of course, just to gather my information in the organized form as ordered pairs. Time is independent variable, and bacteria is, in this case, is the dependent variable. So at time t equals 0, the amount of bacteria is 10 grams. So I can say times 0, there's 10 grams. At time t equals 2, there's 30 grams. And then at time t equals 6, this is the unknown that we're trying to look for. The reason why we need all these three order pairs is because we have a lot of missing variables that we need to resolve. We need to figure out the c value and then find out the k value, and once we have that, then we can use the 6 to plug in and have everything needed to help us solve for b. So let's go with the c first. I think 0 is always the easiest one to start with. So if I plug 0 in for t and 10 in for 10 in for b, I get ce to the 0, which is just e to the 1, e to the 0, which is 1. C equals 10. Once I have my c value, I'm going to update my my bacteria equation. And then once I have my bacteria equation, I'm going to replace my b with 30, and then replace my t with 2. And now, if I divide both sides by 10, I get 3. Take the natural log of both sides. I can work my way to solve for k. Divide both sides by 2. K is 0.5 natural log of 3, or 1/2 natural log of 3. Once I have my k value and my c value, I'm going to dump it all into my general equation. Replace the c with 10. Replace the k with 1/2 natural log of 3. And now I can just plug in 6 and the only thing left for me to do is to plug this in the calculator. All these are now numeric values that can go directly into the calculator, and it cleans up to be 270, and that's answer choice C. All right, number 41, it's telling us to use U-Substitution, so let's go ahead and do that. We're going to plug, replace 4x minus 3 with u. So there's our u value. Our u value is 4x minus 3, du dx equals 4, dx equals du over 4. We make our initial substitution. The parentheses gets replaced with u. dx gets replaced with du over 4. Now here's the problem, is that this x is not going to go away nicely on its own. We don't have any coefficient here, anything from du over dx or du over 4 to help us cancel out. So we need to find a way to get that x to be replaced in terms of u. So the way we get that x to be replaced is we go back to our relationship here that's developed between u and x, and maybe we can solve for x. So we're going to we'll do change of variable here so that we can get everything here in terms of u. So I'm going to solve for x here. I'm going to add 3 to both sides, divide by 4. So I now have a clean replacement for this x. So this x gets replaced with u plus 3 over 4. Or I can just think of it as 1/4 u plus 3. So I don't have to deal with a messy denominator. I can just think of that 1/4 as a coefficient. So I'm going to replace this x with 1/4 u plus 3. And now we have everything in terms of u. Let's just see if we can clean this up to the point where it'll match one of our answer choices. So 1/4 times 1/4 is 1/16. I can take that u to the 10th and put in front of the parentheses, distribute the u to the 10th through. Add the exponents. 10 plus 1 is 11, and then this is 3u to the 10th. And it's not asking us to solve, it's just asking us to match the appropriate form. So this is a problem that is unresolved, but it matches our answer choice.